Welcome to the World Space Week podcast for 2011.
I'm Elf.
And I'm Haritina Mogosanu, Manager of Educational Relations for World Space Week Association.
To celebrate World Space Week 2011, we've put together a series of podcasts to enthrall and excite you with the most interesting and inspiring space stories from across the globe.
And today, we are featuring...
I'm Robert Zubrin. I'm president of the Mars Society, an astronautical engineer.
Could you please tell us, in your opinion, what is it about the current progress in space exploration that makes us willing to celebrate the World Space Week?
Well, the main progress that there's been in space exploration has been on the robotic side. That is, in particular, with Mars exploration. Since I wrote the first edition of The Case for Mars back in '96, we've had a string of successful Mars missions, Pathfinder, Mars Global Surveyor. We had 2 failures in '99, but we pushed through. We had Mars Odyssey and Mars Express and Spirit and Opportunity and the Mars Reconnaissance Orbiter and the Phoenix mission. And now we're getting ready to launch Curiosity. So those have been a tremendous success taken as a whole. And it's enormously expanded our knowledge of Mars and confirmed, actually, the viewpoint that I took when I wrote the first edition of The Case for Mars, which was a plausible viewpoint at that time, that is, Mars was once a warm and wet planet. Now we know that that is true, a place that could have supported life in the past, a place that we can colonize. So that's been great. What has not been great has been the human space program, that there's been almost no progress in human space flight since 1996. There's been no new heavy lift boosters developed. There's been no flights beyond low Earth orbit. In fact, there's been no flights beyond low Earth orbit since 1973. So we have a robotic program moving forward. We have a human spaceflight program that is basically stagnant. And I believe that fundamentally the difference is that the robotic program has definite goals, whereas the human program simply seems to be operating in order to operate.
So there's still a lot to celebrate with the success of the Mars robotics missions, but what other ways is the Mars Society celebrating World Space Week in 2011?
Well, people can go out for a drink. Lots of things you can do if you want to celebrate. There's a lot of things to celebrate. Gone another year without a nuclear war. It's always good. The Mars Society is not fundamentally in the business of doing celebrations. We're trying to move cause forward. And, we have been advocating in the United States for a space program with a real goal, with a destination. It's a very tough fight here right now, but that's what we're doing. We also, of course, have our own program, which is the Mars Desert and Mars Arctic Research Stations, which both get science data and experience and also spreads a vision to the public of human Mars exploration. So that's what we're doing.
I argued recently with a friend of mine who said that humans should not go to space because we're not made for it. Who should then go instead?
Well, the human race is not native to the Earth. We're native to East Africa, okay? That is, people did not evolve in New Zealand or in North America or Europe or Asia. None of these places are actually our native habitat. No one could survive a single winter night here in Colorado without technology, such as fire, houses, clothing. No one could have reached New Zealand without boats. People could not swim there. And we became a global species by virtue of our capacity to invent. And that's why we're able to live outside of our natural habitat of the Kenyan Rift Valley. So think of how much poorer the human experience would be if we had stayed in our natural habitat of the Kenyan Rift Valley. It would be a few tribes in one little place, very limited variety of experience. Instead, we spread across the globe into lots of different countries and developed into lots of different cultures, different languages, different literatures, different traditions, and we, taken as a whole, have become a much vaster and richer experience than there would have been if we had stayed where we belonged. So by going out into space, we have the prospect of expanding the human story in as radical a way in the future as spreading from the Kenyan Rift Valley did, to becoming a global species. We become a spacefaring species where 1,000 years from now, there will be people living on thousands of planets orbiting thousands of stars. Their experience, taken as a whole, will be as radically richer than ours as ours is compared to what we would have been had we remained a local species in the Kenyan Rift Valley.
So why should we go to Mars? Why Mars and not somewhere else?
Well, because Mars is the closest planet that has on it all the resources needed to support life and civilization. It is the richest planet within reach in terms of resources, and there's a carbon dioxide atmosphere and there's nitrogen in the atmosphere. You have all the elements needed for life, and it has a complex geological history, which is necessary to create concentrated mineral ore, which the moon, for instance, does not have. And it has sufficient solar energy, not as much as the Earth, but at the Martian equator, the solar flux is the same as that in Norway on Earth. And so there's enough sunlight to grow plants, and there's the resources to live. If we're interested in creating new branches of human civilization, Mars is the place to go.
Awesome. So what are the current plans for going to Mars? Do we even have one?
I have one.
What's your plan then?
It's called Mars Direct, and it's laid out in detail in my book, The Case for Mars, which, by the way, we just published an updated edition this year. The plan is that by making use of Martian resources, we can scale down the mass of the mission so that we do not need to do on-orbit assembly. And we can do a human Mars mission with 2 launches of a heavy lift launch vehicle. The first sends to Mars an Earth return vehicle with no one in it, goes and lands on Mars, runs a pump, sucks in the Martian air, which is mostly carbon dioxide, reacts that with some hydrogen it brought from Earth to produce a large supply of methane and oxygen rocket propellant. Now you got a fully fueled Earth return vehicle sitting, waiting on Mars. Once that's done, you launch the other rocket that shoots a HAB module out to Mars, containing a crew of 4 people, perhaps. They go and land near the Earth return vehicle. They use their habitat as their house and laboratory on Mars while they explore for a year and a half. And then they get in the Earth return vehicle and fly back to Earth. Each time we do this, we add another habitat to the base. And before you know it, we've created the beginning of the first human settlement on a new world. There's nothing in this that's fundamentally beyond our technology. The question is it beyond the courage of our existing political leadership? That's the real question.
So if we were going to go to Mars now, where would we land?
Well, there's quite a bit of different ideas on that score. I would aim for some place that is low altitude so that we have the thickest air we can get, which is easiest to use. I would go for low latitude, so I'd have a lot of sunlight, but I'd pick a place in low latitude where there is high water concentrations in the soil, and we have mapped out water concentrations in the soil of Mars from orbit with the Mars Odyssey. So those would be how I would direct it. Now, then, finer than that, I would look for places that are within driving range of a fair number of scientific objectives of interest, a variety of geologies and places. Look for water runoff channels, dried lakes. If we could find a place where there's a methane vent, that is definitely a good place to go, because the methane has to come either from a biological or hydrothermal source. If it's biological, that speaks for itself. We want to drill down and see if we can sample those organisms. If it's hydrothermal, a hydrothermal environment is one that can support life. So even if the methane itself is not biological, if it gives away a hydrothermal vent, we definitely want to go there.
Beautiful. So can you put some hypothetical time limit on this? Are we talking years? Are we talking decades, centuries?
We can have humans on Mars within 10 years of program start. And that's how the program has to be conceived. The Bush Lunar Initiative failed because he gave it a 16-year timeline. In 2004, he said, let's return to the moon. We can get there by 2020. Now, it only took 8 years to get there the first time. And that was starting with a culture that had not yet invented the push-button telephone. They were using slide rules, and they were able to do it in 8 years. By saying he was going to do it in 16 years, he basically pushed out the timeline for accomplishment so the program would not be well underway while he was still in office, and made it susceptible to cancellation. You have to think of something like a Humans to Mars program as being like an army on the march through hostile territory, and it's subject to ambush at any time. The longer you keep doing this, the more chance there is the program will be destroyed. You've got to charge across the battlefield. You can't walk across the battlefield while they're blazing away at you with machine guns. That's how you have to do it. If we want to have a Humans to Mars program, we can't do it in 30 years. We can't do it in 20 years. You got to do it in 10 years or less from program start, or you're more or less guaranteeing program failure.
But with the major player NASA on the economic sideline for the next decade, who else do you see providing the next exploration phase?
Well, Is NASA on the side? Okay, NASA is certainly in a state of severe disorganization right now. It has no clear objectives. It is pursuing a random set of technology programs that don't fit together and which therefore will all be canceled because none of them are for any defined purpose. And this includes both useless technology programs, of which there are quite a few, as well as ones that would otherwise be quite useful. For example, a critical technology that we need is a heavy lift booster. That one is one that I fully support. And NASA has just begun, or claims it has just begun, a heavy lift booster technology program, or hardware development program, no less. But it's going to fail because it's being done in isolation from a mission to use it. They're proposing to develop a heavy lift booster and have a first flight in 2017, and they're not talking about a mission for it until 2025. So what are you going to do? Just launch rockets to watch them go, like the 4th of July? It's nonsense. The way we succeeded in Apollo was not by having a bunch of separate technology programs, somebody over here developing a lunar ascent vehicle, and another person developing a lunar descent vehicle, and another person developing a command module, and another person developing a Saturn V. And one day they happened to meet each other and said, you know, if we put your lunar ascent vehicle on my lunar descent vehicle, we could get it to the moon and come back. No, these things were all designed together as parts of an overall plan. Okay, the Obama administration says it wants to do a human asteroid mission. Human asteroid mission is not that hard. It requires a heavy lift vehicle, a HAB module, and a reentry capsule as its primary flight elements. But they all need to be developed, and they have to be developed to fit together. And they have to be developed to more or less show up at the same time. And then you can do the mission, and then you could have an asteroid exploration program, which I have mixed feelings about, but at least it would be something, and it would develop about half the flight hardware elements needed to go to Mars. But they're not. They're pursuing things randomly. They're developing orbital refueling depots for interplanetary spaceships that don't exist. They're developing electric thrusters, but not the power systems for them. They're developing a heavy lift booster without developing anything for it to launch. This is chaos. The first thing we need is a definite goal. And in my view, the definite goal should be humans to Mars, because that goal has a definite purpose, which is to search for life and to see if we can develop the means to support human beings on another planet so as to begin humanity's career as a spacefaring species. So we have to set that goal. Now, once we set that goal, then in fact you could look at more efficient ways to achieve that goal. People talk about SpaceX as a company which is capable of developing boosters at a significantly lower cost than either NASA in-house or its major aerospace contractors. And that may well be. But in order for SpaceX to develop a booster and actually bring it to flight status, there has to be a program to use it. And this will be even more so once SpaceX becomes a publicly traded company, and it can't just do whatever Elon Musk wants to do. It has to report to its stockholders. So we need a NASA that sets definite goals, and once it does that, finds the most efficient way to achieve those goals, instead of perhaps proclaiming dreams and then use those visions as justifications for random technology developments, sort of like a Christmas tree that you hang different ornaments on.